Alright, welcome back Physics 30. Today's lesson is relatively shorter lesson compared to the last lesson about photoelectric effect. It is a little bit of recalling and what I like to call this lesson as graph analysis of photoelectric effect. The material that you need is blank pieces of paper and ruler, like what you see on the screen over here. So let's do a little bit of recalling first. Photoelectric effect. The thing that scientists discovered was photon, your light, EMR, carries energy. So if it's bombarded like particle collision, think about Unit A when we learn about momentum, then the energy will be converted into different form of energy, and that is generally kinetic energy. But there are two different type of energy that you need to consider. Some of them are used as dig up electron. Some of them is literally use it to shoot electron. This energy that is required to dig up electron is known as work function. It's a basic energy, and kinetic energy is like what we know, 1/2 mv squared. Sorry, there you go. That is what we need to understand. And if I draw a little bit of picture, any type of metal atom, blah, 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 have a nucleus, and I have electron that goes around. There's another level and another level, which we learn in science 10. And let's say whatever this valence electron, photon collides, and once that impact is a lot with the orbiting electron, then some of the energy is used to dig them up and then shoot it out. This digging up is W and shooting out is EK. So this is a very pictorial representation of what you observe so far. Now, let's think about it as graph analysis. In diploma, there are quite some question about graph analysis. One thing that you need to understand is our linear graph formula. Y is equal to mx plus b. Is there any way we can apply this linear formula to our photoelectric effect situation? And the answer is yes, there are several. So let's talk about our basic part first. My total energy initially, that is equal to my total energy that you have for final situation. So in this situation, ETI, ETF, ETI portion is basically my HF. This is my incoming EMR photons energy. I'm gonna do some stuff involved with wavelength as time goes too. So HF, that is equal to work function plus EK. Now, as you may notice, this is very resemble to Y is equal to mx plus b. Like for instance, B is equivalent to my kinetic energy, and my mx should be equivalent to my W. So far you may notice that there's no resemblance, but if you actually substitute some of the formula that we know, this is what we get. I can make, I'm gonna use highlighter in this situation, my H into my slope. As long as we know that X, and I'm gonna put X as my independent variable, and my dependent variable Y is equivalent of HF. So in this way we can have our y-intercept, which is b, positive value probably in this case because you start to see a b value with the positive and energy is positive, and this h will be my experimental slope. So how can we draw this and predict this? Here's what we can do. Let's use ruler and just arbitrarily put y-axis and x-axis. I'm only going to do few type of example today, but there will be quite some example. Now, the very first type, and again, it really depends on what kind of question. Talk about x-axis and y-axis, but as the way we learn, my energy, total energy, is equivalent to HF0 plus EK. So in this case, my X can be my EK with Joule. Oh, oops, sorry. See, I do mistake. F0 with the Hertz. And when it comes to my Y, that's my ET with the Joule, something like that. So in this case, know the fact that it is Y is equal to mx plus G. So it should be look like this. My Y, energy as a Joule. Then my y-intercept will be my EK, and then we will have continuing line that will happen. And when it comes to slope, my rise over run between my first point and second point, if you do y2, y1, x2, x1, you will notice that this will give me my h value, which is experimental h value. This may not equal to 6.63 10 to the power negative 34 Joule and S. Or we can even make this as EV and EV. Then we may get H as 4.14 10 to the power 15 EV and S, something like that. But it will be not exactly equal to, it will be experimental value. So that's one of the approach. What about we use a little different approach. We're still going to do y is equal to mx plus b, but what about we switch those? For example, so w is equal to hf minus hf plus ek, something like that. Then the whole thing changes for a bit, because first of all, this f is my frequency. So what type of frequency? This is in fact my incoming EMR frequency. So my slope itself is a negative, so that means I have vertical and I also have horizontal like this, and you will have down slope, going down type of slope. We may have EK as my y-intercept, which is equivalent as B over here, and my X should be my frequency, Hertz, something like that. Then you will know that whatever the points over here, difference between should be my H experiment. That's another way. As you may notice, my B value is quite evident. Now, 3. What if we are doing exact similar situation? E is equal to W plus EK, but instead of frequency perspective, we have lambda wavelength as a perspective. Then you need to understand that this is my experimental lambda value. As soon as you see it, some people try to go, oh, Mr. Kim, this is one of those 1 over x situation. Please don't go there. Rather, we can separate in this way. E is equal to HC as my slope, and you have 1 over y experiment value like this plus ek. Then you will still going to have y-axis, x-axis with any type of slope that go up like that. Except the only thing is 1 over lambda is my x. So we know that it's ek, and the slope between those will be basically indicating my HC value. Of course, it's experiment value. Then in that case, what you can do is, well, H experiment is my slope minus 10 to the power of 8 meter per second, and that's what value that you will have. So in conclusion, today's lesson involved how you can manipulate several different type of formula that you have for any type of energy or wavelength, frequency, and how you can do some manipulation in graphical analysis or analyze the data if there is a graph that is given. Rarely you will have table that is given. You need to understand a graph analysis. That is my today's lesson. Your homework is completing that photoelectric effect, any type of question that you miss. I believe last time I gave you 5 questions for A section.